Go for it,
All
Bob.
right.
Let's see, where's my, here we go.
Julian, you ready to kick it off then? Seems like
Yep. Let me get my notes here. Okay. All righty. Hello, everyone, and welcome to the CQ Blind Hams Techzoom for August 2023. This is a meeting of blind hams. We get together, and it's kind of almost like a network club meeting, if you will, except we do it virtually. And we have various guests and topics. And of course, we cover things amateur radio from a blindness perspective. So if you're not here with us today, you're listening on a podcast, and we thank you very much for listening to CQ Blind Hams Techzoom. If you want to learn a little bit more about the Blind Hams group and all the various ways that we have of contacting us and getting onto our bridge and interacting with us and all the fine nets and things that we run, as well as some very valuable and helpful resources, please be sure to visit blindhams.com. That's www.blindhams.com. So it goes without saying, we are being recorded. So anybody who doesn't want to have their voice on a recording, I guess you're just going to stay muted the whole time. But we really encourage you to speak, because the more participation, the better. If you're not familiar with Zoom, there's something that probably popped up on your screen that tells you that you're being recorded. If you don't hit the got it button, you will not be able to interact with your meeting controls. So if you haven't done that yet, you want to do that. At this point, anybody who is not going to be presenting or hosting, please mute yourself and remain muted until we open the floor for questions and comments. That way, that keeps things nice and clean for everybody participating, as well as the listeners, and it makes it easier to do edits and things like that. We ask that you wait to be acknowledged before speaking, and we don't. And let's try not to talk over each other. So again, just to keep things clear and stuff. So without further ado, I'll go ahead and introduce our hosts and crew here. I'll kick it over to Joel, W0CAS. What's going on over there in North Carolina?
well, about the same as usual, just weather and storms. But fortunately, I've got my 97-foot end-fed antenna in my attic, so I don't have to unplug. I don't think. Haven't had any trouble yet. Looking forward to tonight's talk. It's been one we've been wanting to hear for quite a while. So we'll give it back to you, Julian.
All right, thank you. And let's see, is Robert NC5R with us tonight? I didn't hear him earlier.
No, Robert's playing music tonight.
He's playing
open
music.
mic.
All right. And Steve, WB2KTV, is he gigging with him as well? Or?
Good evening, everybody. Steve,
Oh, there you are. You snuck in there.
Oh, I tend to do that. I'm an ex-HFer, only because I live where HF cannot go, a little cracker box apartment in Manhattan. So, but I listen a lot, so I know what's going on the bands, and looking very forward to tonight's talk.
All righty. And Angelo, I know, is there in the background, currently in the midst of storms, but I'll send it real quick in case he wants to say a quick hi-bye or something. No, I guess not. Last but not least,
Thanks,
is
Julian.
me. Oh, there you are.
Yeah, how you doing, everybody? Glad to see you there. Yeah, we're in the midst of thunderstorms, so it knocked out the internet. We're using the telephone hotspot. So, and Bob, I didn't know if you had a slides or anything, but I made you a co-host so you can show your slides if you need them. All right, have a good time, folks. This is going to be a great one. Back to you, Julian.
All right, thanks, Angelo. Thanks for setting all this up, and now go be safe from the storms. So before we get to our guest tonight, I just want to talk a little bit about CQ Blind Hams YouTube channel stats. I'm going to call Joel in here in a second to help fill in some of the details and further explain these numbers. But in our last meeting, we talked about needing to get over the 500 subscriber mark. I'm happy to say that we have done that now. In fact, We have added 137 new subscribers over this last month, which is a good thing, but we certainly could use more, because the more the better. We've had 818 total views, and altogether 5,532 minutes of our material watched over the last month. So these are all good things, and these are all numbers that need to continue to increase. We all need to spread the word about the CQ Blind Hams YouTube channel. There's a lot of good stuff there. Our content is helpful not just to blind people, but even I've shown sighted people this channel, and they've found it to be very helpful as well. And part of it is because I think, because we're doing it from a blind perspective, we're narrating things in a different way and not just relying totally on, okay, yeah, you click here, you point there. We're giving verbal explanations, and I think that's helpful to a lot of people. So the bottom line is, the more subscriptions and the more views, the more money we get as the channel gets monetized. And this is money that gets put to use in a very good cause. It helps us to buy radios and accessible equipment like that to put in the hands of blind hams, especially a lot of who are new to the hobby. So it's a good thing to try to get these radios and these things into the hands of new hams to help join our community and keep the hobby flourishing. So Joel, you want to say anything about those numbers?
That's about it. We have got 567 subscribers as of tonight's viewing. So like you said, the one thing that I didn't notice when I started asking for subscribers was the view hours per year. And it says we need 3,000 watched hours and within 365 days before we can monetize. And like I spoke of last month, we're going to take every penny that we get and put towards buying new accessible radios so we can have them available for new blind hams. Once a blind ham gets their ticket, we'd like to be able to hand them a new radio so they can get on the air immediately. So that's what the money is going to be used for. It's not any profit thing. It's something that we can help out new blind hams.
Yeah, I think that's awesome. And I guess we got to get watching. So is that what needs to happen? We need to subscribe. That's important, but not just subscribe. We need to go on there and view. So just go on there. Even if you're going to listen to this podcast, I know it's available on a lot of the podcast applications, but if we stream it through YouTube, that's important because it helps us with the monetizing. Is that correct?
That's correct. And I created 2 playlists yesterday. I figured out how to do that. That wasn't as hard as I thought it was going to be. So if you're just browsing around on YouTube, you go to CQ Blind Hams, click on the one that says Techzooms, or you can click on the playlist that says, I think I named it tutorials and demos, and just click on one of those and let her play while you're cleaning the house, doing dishes, whatever. Just have it going on in the background. That'll help us out.
Yeah, it's kind of handy to do. Sometimes with YouTube, I like to Chromecast it over to the TV, which is going through the nice stereo speakers. So sometimes it's a nice way to enjoy a podcast or enjoy a video in nice full fidelity. So spread the word, get subscribed. If you're not subscribed, get your friends and family to subscribe. And let's get those views up so that we can monetize this thing and help put radios in the hands of blind hams. So without further ado, I will go ahead and introduce our guest speaker, who is no stranger by any means to the CQ Blind Hams Techzoom. He's been with us before and always has interesting things to say. It's Bob AK6R from Palamar Engineering. And today he is going to talk to us about end-fed antennas. So without further ado, Bob, go ahead. The floor is yours.
Okay, thanks. How's my audio? Is it all right?
It sounds good to me.
All right, very good. Well, I want to thank you for having me back. Thanks, Joel, for reaching out. And fortunately, we got a good date today. And in fact, I'm doing 4 more of these this month. So you're the first one. So I'm happy about that. And thanks, Julian, for being a host and recapping all that. And Angelo, I should be able to share a screen if I heard you right. So I do have a PowerPoint presentation tonight, and a lot of it I repeat as I'm speaking. So if you don't get all of it, you'll at least hear of it. So let me go share a screen now and go find the one I want. Let's see. I think it's this one right here. Okay, I think everybody should be able to see that now. And tonight we're going to be talking about multi-band end-fed antennas. So these are not just single band; these are multi-band and much, much more. I have a secret topic tonight, which I want to show you, and it's about antennas. So I hope you're interested in that too. But we redid this talk and have added a few new types of antennas to it, which I think you'll find very interesting. So let's go ahead and proceed. For those of you, let's see if I can get this to go ahead one here. Okay, so as I did before, for those of you who don't know much about Palamar Engineers, it was founded in 1965 by Jack Althouse, K6NY, who passed away to about the age of 92, and he was still working CW 2 days before he passed away. And he was that was about 2013, so about 10 years ago. My wife and I bought the company. It was in a 10-foot by 10-foot storage area. And with all the engineering drawings that were in there, they were all in pencil. He had never gone to pen. So it was kind of fun. And I have copies of all of the old manuals and stuff. And we've posted those on the website for any of you hams who want to look at some of our old products or come across one in a swap meet or something and you need a manual for it. They're all up in the websites. We reorganized the company into an RFI solutions company, got very much involved with lots of different types of filters. And we also started making balance, really, really good balance and ununs. And we make them a little bit differently than everybody else does. And they're very, very broad band, similar to what you'd see in a solid state linear amplifier output circuit, for example. We virtually don't use toroids or rings in any of our products. We use beads, and it's a much easier way to do it. And you'll see a reason for that as we talk about the antennas. We wanted to provide products to make amateur radio communication more effective, more enjoyable, and less expensive than it has been in the past. So most of our products are very well priced, and you get good value for what you have. Our product line consists of ferrite core products, which are ferrites and typical, and that's what we talked about last time for RFI. But we do have a lot of balance, ununs, feed line chokes, and coax noise filters. And we'll talk a little bit about those tonight and some of the alternatives for end-fed antennas, at least. We do have antenna systems, complete ones, or you can do it yourself. We have off-center fed, end-fed loops, and terminated antennas with big resistors in them, very good listening antennas and very broad band, used by a lot of the government agencies around the world, actually. And then we have RFI solution kits for hams, for your household, for marine, RV users, those types of things. And then if you remember Kurt Sturba, that was Jack Althouse's alternate name. And he used to write in CQ magazine for almost 20 years. And I put up all those books and all his articles for free download if you want to get it off the website. They make really funny reading, a lot of comedy in them, but also a lot of facts and interesting. We distribute through ham radio outlet and direct, and also sell a few items on eBay from time to time. And we hit the consumer, commercial, and the military markets. So a little bit, that's about what we do at Palamar. It's been a fun operation. I bought this company because I wanted to create a company that was fun to operate, and it's certainly been that for sure. We've got about 20 people working here indirectly, and we hire a lot of retired people so that they have something to do and can earn some extra money for projects that they may have. Okay, let's go talk about end-fed antennas and get right into it here and see what we can come up with. Tonight, we're going to be talking about, it takes about 45, 50 minutes to go through this talk, and then I'll stick around as long as needed for a Q&A, so no problem there. I'm going to do a short overview of what antenna feed point options are. In other words, where do you feed an antenna, and why would you ever want to do it at the end when you could feed it in the middle? And there's lots of reasons for that. We're going to talk about dipoles, off-center feds, ZEPs, do a little overview of that, and then look at popular end-fed antennas. And the three that we're going to be talking about tonight are resonant end-fed antennas, and they've become very, very popular in the last couple of years. We're going to talk also about non-resonant end-fed long wires, and that's what our 71-footer, and that's the crux of most of our antennas that we've been selling for the last 7 or 8 years. And we've introduced this year a new antenna called a resonant end-fed long wire. And essentially, it's an off-center fed that's end-fed, if you can believe that. And we'll show you exactly what that is. It has some very unique characteristics, and it's a little bit shorter with more bands and a little bit better SWR graphs for quite a few of the bands. So we'll show you some examples of that. We'll talk about typical configurations that work all the time. Like I said, we have so many of these antennas out. There's all different types of applications in attics or around the gutters, along fences, zigzagged here and there, but I'll show you some of the more popular ones. And then next we'll talk about how do you choose one? You're going to have a lot of alternatives here. Well, which one do you think is best for you? And that's a matter of which bands do you want to operate? How much space do you have? How much power are you going to run? Those typical type of things. And then going along with end-fed antennas, we'll talk a little bit about feed line chokes and some of the problems that antenna switches create in the ham shack, no matter what type of antenna you have, and how you can get around some of those problems. And then we're going to talk about a special topic. That's the one we're going to end up with, and then we'll be around for questions and answers. So let's put our thinking caps on and talk a little bit about the different ways that you can feed an antenna in general. And most of you are probably familiar with center fed. And then we're going to talk about off center fed and then finally end fed. And there's disadvantages and advantages to each of those options. So the first one we're going to talk about is, and we're going to use an antennas that work from 40 to 6 meters, although the principle also applies to 80 through 6 or 160 also, but I've got a lot of the graphs already set up for to use 40 through 6 meters. So we're going to use those, but like I say, the principles are the same for different band ranges. So a typical center fed dipole, it's fed equal on each side. However, as you take the dipole lower and lower to the earth, the impedance will also change. And one of the things that you can do in order to have proper matching is you can offset it just a little bit, because as you move the feed point from the center to the end, the impedance will go up. So if you have a real low dipole, for example, 10 feet tall, and you're working 40 meters, the impedance is going to be about 25 ohms or less if you feed it in the middle. But if you just offset it a little bit, you can get back to 50 ohms and get your SWR back, and the antenna will radiate just as well, and you won't have any of the SWR issues. So this is just an example of one such antenna here. It's fed 29 feet on one side and about 32.5 feet on the other side. And it's a low antenna, like when you were going a portable operation or something like that. But you can feed it that way, and it matches just fine, just like a center-fed dipole. Typically, they're good for one band or maybe the odd harmonic. So, for example, a 40-meter one would probably work on 40 fairly well, and also on 15 meters, which is the third harmonic. So anyway, that's just an example of a center-fed or a little slightly off-center fed antenna. The next step up is an off-center fed antenna, and there's quite a few ways to do off-center fed antennas. One way that you see just about 95% of the companies do is they use a 1/3, 2/3. In other words, the short side is 1/3 of the antenna total length, and the long side is 2/3. Well, if you do that classically, the problem with the antenna is, at least on this one, for example, 40 through 6 meters, is you do not get 15 meters. it will not resonate on 15 meters. So if you change that offset just slightly, and in fact, our case, we found that an 18% and an 84% offset allows you to work all the bands, including the work bands, including 15 meters. So you get more bands with the exact same length of wire. And that's what I like to do. I like to optimize the wire by changing the feed point just slightly so you get more bang for the buck, so to speak. So this is an example of how you would use an off-center fed to do that. OCFs are very good antennas. They're very good multi-band antennas. And in fact, if you, we'll go to the next slide here, you can see that this is a slide of SWR from 1 megahertz to 30, and there's also a slight extension for 6 meters there. But you'll see this is the 3-to-1 SWR line here, and you'll notice this is the 2-to-1. Just about all the bands are below 2-to-1. In other words, you probably don't need a tuner on most of the bands that you want to operate. And if you do, you can generally use the tuner that's either in the radio. They're typically good for 3-to-1 and below without having to have an external tuner. And they work very well. So keep in mind that the off-center fed in this case is about 18% and 82%. So it's not quite the same as everybody else. The advantage is, of course, you get more bands for the same wire. And why not do that? There's about 1,000 of these in use in the United States and all around the world. And so they're a popular antenna if you have the room to stretch it out horizontally or as an inverted V. Now, when we talk about end-fed antennas, we also have several different options. All right. Some of you know what a J-pole is if you're familiar with VHF and UHF. Well, there's also an antenna called an end-fed ZEP, which really is just a J-pole, but it's folded on its side. And we'll show you a picture of that in a minute. There are end-fed half waves, which are a half of a wavelength on the fundamental frequency. And then there are non-resonant end-feds, and that's what our 71-footer is. It's not resonant in the ham bands, all right? And it has two parts. One is the wire and one is the counterpoise. And most people just use the coax as the counterpoise with a choke on it. The last type of end-fed rather is a resonant end-fed. And this is very similar to the off-center fed that we just talked about. But imagine this. We just take the short end of a regular off-center fed and we chop it off. We put a choke the same distance down on the coax. And essentially we have all the characteristics of an off-center fed, but with a much smaller length of wire. All right. And we'll show you some examples of how that works in a couple minutes. But that's a very useful antenna for a bunch of reasons. Okay. Let's take a look at the end-fed ZEP antenna. Been around for probably close to 100 years. I used one of these when I was a novice radio operator in the early 60s. And they're good for a half a wave. They're half a wavelength long at the frequency. So for 40 meters, they'd be about 66 feet long. And the quarter wavelength matching section, typically made out of 450 ohm or 300 ohm or 600 ohm ladder line, really doesn't make any difference. But they're a quarter wavelength long. They're shorted at the end. And then you just tap up until you hit the 50 ohm point with your coax. And that's a very good low SWR, nicely matched single band antenna. All right. However, it also needs a choke just like any other one. And so that's how it works. If you're familiar with a J-pole, all it is, it's the same antenna, except that you're using slotted pieces of metal rather than wire and ladder line. And you're doing essentially the same thing. You're tapping up from a shorted bottom where the coax is connected, and you just match it for 50 ohms. They work very well, and they're good single bands, or they're good at the harmonics. So a 40 meter ZEP would work at 40 and 15, just like the 2 meter one works at 2 meters and 450. Very similar, just different sizes. That's all. And
excuse me, Bob, just 1 second. Has everybody got their phone or computer muted? Because I keep hearing a little background noise, and I don't want to distract Bob to have to do this. But could everybody make sure you're muted real quick? Thanks, everyone. Sorry, Bob.
No problem. Always time for a commercial. It doesn't bother me, by the way. I wasn't paying much attention to it. So, all right, so let's talk about the actual end feds that most of us are familiar with. And one of those is we had a product that we brought out about a year ago, and it's called an end fed half wave. And it typically is a half wavelength long. We decided to use the 40-meter band as the half wave. And it was 66 feet of wire. And it had a matching unit over here, which was a 49-to-1 transformer. And because when you match a end fed, way at the end, the impedance is very, very high. And so you need a high impedance. And in this case, it multiplied it by not quite 50, got you almost up to 3,000 ohms. The problem with high impedance transformers in general is they're not very broadband. They're good for maybe 8 to 10 megahertz. And after that, you have to compensate them and you have to do all kinds of fancy things to make them work. That's why a lot of the end feds they work great on 80, 40, and 20, but once you get up to 10 meters, they have high SWRs and stuff. Anyway, make a long story short, we came out with this end fed about a year ago, and it had 66 feet of wire in it. And we also did use a choke on the coax because it tended to match it a little bit better. And I'm going to show you a configuration here of what it typically looks like. And these configurations there's lots of different configurations, as you can see here in the lower left-hand corner. And we'll go over some of those specifically a little bit later. But you can make these slopers up or down. You can make them flat. You can make them totally vertical. It really doesn't seem to make too much difference in terms of matching. All right. So in this case, we have a 49-to-1 on up here. We have a wire coming out, and it wasn't quite long enough, so we just dropped it down a little bit. You can do it that way, or you can drop down the on and then take this out straight. Either way will work just fine. And then so many feet down, in this case, it was 16 feet down, we put a choke. And that's how this antenna was sold. And we sold quite a few of these. And but there was always something that bothered me about them. And it wasn't the SWR, but I'm going to show you that right now. The SWR in these antennas is really only good for 4 bands. This is a 40 through 10 one. It's good at 40, nice dip on 40, nice dip on 20, nice dip on 15, and a nice dip on 10. All right, all below 2-to-1. But it always bothered me. It said, I'm so familiar with off-center feds and other types of end feds where I get dips here in 12, I get dips here in 17. In some cases, I even get a dip on 30. I can only work 4 bands with this 66 feet. So something said to me, I can do better than that with 66 feet of wire. The other thing that I wanted you to caution you about is anytime you feed an antenna at its very end, like this one right here, and it's exactly a half a wavelength, you have very, very high voltage where you're feeding it. So you have to be careful, all right? In fact, I put together a little table here for you, all right? And depending upon the number of watts that you're running, if you're running 100 watts, there's almost 500 volts at the terminal of that little end of that unknown, all right? If you're running 1500 watts full power, you have almost 1900 volts. Very dangerous unless you put something around that feed point and make sure that kids and pets and other people don't come next to it. And that was one of the major reasons, that and the fact that I think I could do better with 66 feet of wire, that we discontinued that antenna about 2-3 months ago. And because I think there's a safer one, it's shorter and it's far superior in terms of how many bands that you can get off of 66 feet of wire or shorter. So let's talk a little bit about the 71 footer, which is the non-resonant end fed, which some of you use. And we make that in all different sizes and shapes and also lengths. We used to make them in about 10 different lengths. And then we finally changed so that the 71 and the 155, which are our most popular, we sell most of those. But if you wanted a length of 77 or 97 feet, for example, we'll certainly make you one for that. And as long as you have the proper counterpoise that goes with it. But in most cases, you have a 9-to-1 matching on. You have a length of wire, and then you have a choke that goes on your feed line. This is RG8X. You can also use LMR 400. It doesn't make too much difference because there's very little loss on 50 feet or less of this cable, and you can in fact run 1500 watts through it all day long, and it's not gonna hurt it. By the way, I should mention that our ratings for our ununs are pretty conservative. I've been able to take the 500 watt one here and run 500 watts digital through it and more all day long and not have a problem with it at all. That doesn't saturate. You try that with another brand, an MFJ or something like that, and they'll saturate at about 100 watts of FT8, and it doesn't. They don't work very well with high power. Ours are built like tanks. I'm a former RTTY contester, and I like to make sure I keep transmitting and not having to wait for balance and ununs to cool down. So all of ours are very conservatively rated. The configuration for these antennas, the non-resonant ones, and these are the 71 footers, for example. The wire is typically 71 feet long. And as I was saying before, it can zigzag, it can go in attics. We have lots of retirement people down in Florida. Like I have one retirement center down there, and they have almost 100 bullet antennas, and they're all hidden along the periphery behind the gutters of their condominiums and stuff. And they still work just fine. They get on the air and they're always talking with nets and that kind of stuff. But anyway, the wire in this case is generally 71 feet. You put a choke at the 42-foot mark on the coax down here. And the resonant frequency, that they're called non-resonant because they're not resonant in the ham bands. And in fact, if you do the computations, the total length of the antenna is 113 feet because the coax, the outside braid of the coax is radiating just like the wire, right? So don't fold it up, keep it up as high as you can. If you have to fold it, you fold it. But in general, it's part of the antenna, just like an off-center fed. And in fact, these act just like off-center feds. They're just not resonant in the ham bands. But because of that, they have some characteristics that are very useful. If you use an antenna tuner, and in some cases you do, in some cases you don't, you can work 80 meters and 60 meters with only a 71-foot antenna. Now, normally, if you had an end-fed half wave like we were talking about before, you'd need 134 feet to even consider that. With this one, 71 feet and a good antenna tuner, you can work the bands below 40 meters fairly consistently. You have to go to 155 feet of wire and about 100 feet of coax in order to work 160, however. So just be aware that there are different lengths will have different bands, and we'll show you what those are later. We have about 4,000 of these antennas out, and thank you guys for being part of that. And we sell them through HRO and also direct, and you can generally call our technical department, which is me for the most part, and talk about how to put it in different situations inside. We even make one that's down to 41 feet with a 12-foot counterpoise, which will work 40 meters and up too. So FYI on that. Some of the SWR factors, you can see this is the 71 footer. This is the 2-to-1 mark here. And you can see just about all the bands in band are very 2-to-1 or less all the way across. And certainly they're under 3-to-1 for just about everything, which means that they're all tunable with the tuners that are in most radios with antenna tuners. Even the older ones will work just fine with this. And I've had reports of people even working 160 with it, but I haven't. I still can't believe it, but I guess they do one way or the other. They must have really good antenna tuners. But certainly with 114 feet of wire, you should be able to work quite a few different things. Now I'm going to take you to a different concept altogether. It's called these were non-resonant end feds because they're not a resonant length frequency. However, there's a different type of antenna. It's called a resonant end fed. All right. So remember, I was talking about taking the off-center fed antenna and taking off one of the sides, the short side, And instead of having the short side on it, we're going to put a choke at the same distance that the short side is. So our off-center fed that I gave you the example of before, the long wire was 55, the short wire was 12. So if we take off the 12-footer and we put the choke at the 12-foot mark on the coax, and also we change from from a balun to an unun, by the way, because it's unbalanced. A slight change there. You can then work all the same bands that the off-center fed did at a better SWR than the other antennas. So this is an example, and we started selling this about 3 months ago. It's been a good seller for us, and it's also morphed into different length antennas for different band ranges, which we'll show you in a couple of minutes here. But it has a 4 to 1 in here rather than a 9 to 1. And our 4 to 1, our ununs, by the way, they'll go from 1 megahertz almost to 200 megahertz flat, under 2 to 1 SWR. Nobody else that I know of can do that. And the reason is because we make them completely different than everybody else, and they work just wonderful. Our balanced 4 to 1s will go almost to 250 megahertz. They're absolutely one of the best I've ever seen. But anyway, in this case, they're a little bit larger if you have more ferrite in them than they are if they have 500 watts. And we also make these in a box format where they're 5,000 watts too, if you really want to get excited about it. Here's an example of what we were just talking about. But in this case, instead of like the off-center fed or instead of the 71-footer, we only have 55 feet on the long edge, and we only have 12 feet down here. Now, when we were talking about the off-center fed, this 12 feet was over here as the short part of the off-center fed. Well, I got to have coax anyway, so why don't I utilize it as part of the antenna? And so we don't put a combination 4 to 1, 1 to 1 in here like we do with our off-center feds. We just make it unbalanced, and we make the braid part of the antenna until where the choke is, and that's where it stops. And then electrically, it's just coax all the way back to the radio. But from an antenna standpoint, it's radiating this 12 feet plus this 55 feet out here. So the question is this better or is it worse than the other ones? Well, there's a couple of things you can say. One is I got rid of my length. My length is less than the end-fed half waves, which are real popular. I also got rid of my 1,000 volts here, or 500 volts at 100 watts. I now have very low voltage, in the terms of, 10, 15, 20 volts. I don't have 500 volts here. So it's not a dangerous antenna if this part is low or it's close to the ground. You still have to, as usual, always protect people from hitting it while you're transmitting, but it certainly hasn't got the potential of high voltage like the end-fed half waves. And you'll find out in a second as we look at SWR that it compares very favorably. The coax does radiate, which is fine. It gives you additional, and typically it's, if you put the matching unit high, you get a vertical component to your radiation, good for DX, and you still have the horizontal over here for regular close-in type contacts. And it also uses a 4 to 1 rather than a 9 to 1, which is easier to match, lower voltage, a little bit more safe. So let's take a look at the SWR on this one. The SWRs are very good. And you can see, by the way, remember on the regular old end-fed half wave, we only had dips at 40, 20, 15, and 10. Well, here we get dips at 30. We got a nice dip. It's not real low at 17, but certainly it's not way up here like the other one was. It's about 2.5 to 1. At 12, we got about 2.5. And we can even work 30 meters with it and still have under 3 to 1. So our internal antenna tuners will still tune this antenna very nicely. All right. So you get all the bands from 40. And in fact, I don't show it, but you also get 6 meters here. And on our website, I actually show all the individual band SWRs rather than the whole thing, so you can see what it is. But on most of the bands, it's under 2 to 1 for the whole band, including 6 meters. So this is our resonant end fed. So I did a graph a couple of days ago, and I compared the end fed that we were just talking about, the resonant one, all right, which is 55 feet. And I compared it with the graph of the SWR of the 71 footer that quite a few you have. All right. The 71 footer has the advantage. You can work 80 meters with it and probably 60 fairly well. However, on most bands, the 55-foot length rather than the 71 has a little bit better SWR on the fundamental bands. It's about the same on 17. It's better on 15. It's a little higher on 12, but on 10 meters, it's lower. So what have we done? We've taken a antenna formerly 71 feet long, and using a 9-to-1, and I've taken a 55-foot piece of wire and 12 foot of the coax, and I've created an antenna with lower SWR and in shorter space. So that means more people can use them. They can put them in, and that's 55 feet of linear space. But you can, if you zigzag it, you can probably fit it in 30 to 40 feet of horizontal space if you do it right. You can put 90-degree bends in it. There's lots of different ways to put it up, but you get more bands. You get a little bit better SWR, and it's shorter. So I figured, well, that's a pretty good compromise. And so we've been able to put that together, although we still sell an enormous amount of 71s because they are so popular also. So if you're tight for space and you need to work the same bands, here's an alternative that you can take a look at. And in fact, I put together a little table here. And by the way, this presentation is on our website under presentations, and there's also a Adobe PDF file that you can download with all the slides in it exactly as you see here. But here's a comparison between the end-fed half-wave, so popular by all the other guys. You can only work 4 bands with it, unfortunately. And it does have the high voltage problem. The 71 footer that you all have takes a 42-foot counterpoise, but you can work 80 and 60 plus all the other bands. All right. The resonant end fed, shorter, to only a 12-foot counterpoise, so you don't have to have 50 feet of coax. You only need 25, and you still work all the bands. It just like you do with the off-center fed. It works the same bands, and in fact, the SWR for the 40 through 6 resonant has a very similar SWR curve as to the OCF, and the radiation is virtually identical. So if you like horizontal antennas and you have the space for it, use the OCF. Otherwise, use the end fed with the 55. If you want to work the higher bands, the lower bands, excuse me, then you can use the 80 through and 60 on the other one. You just have to have a little bit higher counterpoise. Okay, so let's do a quick overview here, and you'll see that the end-fed half-wave, major disadvantage is the high voltage standpoint, which I just personally don't like. I just don't like high voltage on an antenna so close to the feed point. You get no work bands, you get no 6-meter coverage on those either. The non-resonant, the 71 footer, you can work all the bands with the thing. And some bands require a tuner, but it still works all the bands. And the coax does radiate. You get a little bit of additional band coverage because of that. The resonant long wire, similar output. You get a few less bands, but you got less length, and you still get to work 6 meters and all the other bands. So I think it's far superior to the end-fed half-wave, a lot safer. And that's why we discontinued the half-wave antennas altogether. I just didn't like the safety aspect more than anything else. And you can get more bang for your buck with a shorter piece of wire just by changing it, and it's a lot easier to deploy. Okay, so how do you set these things up? So I'm going to answer 4 real quick questions here. Is how to determine which length to use, and we'll talk about that. How to match it to the coax. For the do-it-yourselfers, choosing a configuration, in other words, what size, how do you set it up, and those types of things, and then choosing the feed line choke, and and adding a noise filter if you need it, and also solving the problem that most antenna switches have with noise. So let's take these, and first of all, let's see how long they are. So I put this together in a couple different slides, and the first one is the non-resident one. And when you asked about the 97 footer, the 97 footer was in here also, and it had the same band coverage as the 71 footer, except that 80 meters was a lot broader and 60 meters had a nice dip in it. So the longer that the wire is, the broader the low band dips are. Anything above 40 meters with either one of these is under 2-to-1. You don't even need a tuner. They just tune very nicely. When you go up to, when you want 160 meters, you got to go to at least 155 feet of wire, and it takes a counterpoise of at least 95 feet. So those are both sold at HRO. We sell them direct, obviously, and they've been good sellers for us. There's over 4,000 of these antennas out, and they've been very popular, and we get good reviews on them also. The resonant end fed now has a couple different options. All right, and it really depends upon which band you want to cover. So if you're in an apartment, I think I heard somebody say they're in an apartment, they can't get on the air. Well, here's an antenna that's only 27 feet long, all right? And it needs a 7-foot counterpoise or a choke at the 7-foot mark on the coax. And now you're on 20 meters through 6 meters, right? You can get on the air. If you do the one we've been talking about, the 40 through 6 meters, you need 55 feet and then 12-foot counterpoise. If you want to do a bullet on 80 through 6 meters, by the way, it's 95 feet of wire, 40-foot counterpoise. And if you want 160, we have to go a little bit longer than the random one. It's 205 feet. But on the other hand, the counterpoise is 40 feet less. So it's a 55-foot counterpoise. You can probably get away with 50 feet, and it would still tune just fine. So your alternatives really for the bandwidth or the bands that you want to operate depends upon how much space you have. What we tried to do with this antenna was give you more bands with less wire, so that it would fit in smaller spaces and or be more easily hidden from prying eyes, so to speak. Okay, so what types of configurations can you set these up in? Well, there's lots of different ones. Some people use a straight, they use a vertical fiberglass poles that are telescoping. They just put them straight up like this, and maybe off a little bit to the side if necessary. A lot of people just run them as inverted L's. They put the matching unit low, and then they run this here. They go up to a tree, for example, and then they go out as long as they can. And some people put them way low, and they run them as slopers up, or they run them as slopers down like this. Now remember, the coax also radiates, so the sloper down is actually a pretty, or straight across, is actually a good location, because now the coax is vertical, and you're getting some vertical radiation out of that, which is good from a DX standpoint. You can slope up or down. You can do inverted L's. You can zigzag. You can actually take this wire and zigzag it like in an attic. I've heard lots of people doing that. You can do a 90-degree bend in it like this, or you can do a 90-degree bend that's horizontal. I have one that goes out, I think it's about 30 feet tall. It goes out about 40 feet to a tree, and then it turns 90 degrees and goes out another about 100 feet to another tree. And it still works just fine. I have no issues with it at all. And by the way, I measure the efficiency of these antennas. I work a lot of FT8. And the reason I do that is because I can get reports all over the world, and they're digital. And they give me specific reports in different locations. So I can not only look at radiation patterns, I can actually get signal reports. Even though I'm not working the guy, there's so many people out there that I can download or see real time exactly what people are hearing me, where they're hearing me, and what the signal strength is. So I can compare different antennas and stuff. And it's been very, very helpful to do that. And what I found is that it really doesn't make too much difference how you configure these things. They all get out. They all seem to work. However, I've noticed that if the matching unit is high and you have coax that's radiating vertically, you do tend to have a little bit better DX in my case, Europe but also into the Middle East. We do very well into the Middle East here on with these antennas. In fact, I've worked people in in the Philippines on 6 meters with these antennas on FT8. So I know that they've got quite a good gain once you get multiple lengths on of wavelengths on it. Some of the SWR factors that you'll run into, regardless of how you set it up, it depends upon the shape. Okay, sometimes if you would do it as an inverted L, the SWR may be a little bit different than if you do it as a flat top. And so you have to experiment around. And a lot of it is a function of your soil conductivity, if you're close to the ground, or how close you are to a metal object, and whether you're feeding it at the top or the bottom, et cetera, et cetera. So it's a good antenna to experiment with, but no matter how you put it up, my experience has been, and the customer feedback that I've gotten is that it's a pretty good antenna for all different types of installations, some being better than others, but as long as you can get on the air and make contacts and with your friends and have a little DX and take part in all the different radio things that you want, it's a good antenna. As far as matching the coax to the antenna, it really depends upon what type of end fed that you're using. The ones that I mentioned here, I also mentioned the 49-to-1. We don't sell that unon at all anymore. People were putting it on oddball lengths and it was blowing up the ununs, and they were blaming us for the problem when in fact it was their own design errors that were causing it. So we only sell the 9-to-1s and the 4-to-1 ununs in all different size ratios. The 9-to-1s are good for the non-resonant antennas, and the 4-to-1s are good for, of course, the resonant and fed antennas. The 4-to-1s ununs are also good for I think it's 57-foot verticals too. They're useful for that. There's a couple other applications besides just the ones that we're talking about here. The connections for the coax, there's connections on the ununs for the coax and for the feed points and those types of things. And here's some examples of the different sizes and availability. We make them in a 100-watt version down here for people who want to go portable, or they're only running 100 watts. These run just fine. And we also make them in 500-watt, 1500-watt tubes like this, and then also 1500 and 5 kW tubes like or boxes like this, because people want to mount them against a wall, for example. They're virtually identical in performance in terms of SWR graphs and things. And if you do look at these products on our website, there's SWR graphs for every one of these things, usually from 1 megahertz all the way up to at least 60 megahertz. So you can see how they compare with some of the competitors. And I guarantee you they'll be better. Let's put it that way. Don't ever buy a balun or an unknown, by the way, unless you know what the response is. If there's no SWR graphs or there's no technical information going along with it, just say pass and come over to the Palamar site and be welcomed with great products. We sell thousands of these a year, so we know they work really well. You do require a feed line choke with all these antennas. And you basically have two options. One is a simple ring like you see on the left-hand side over there. And you can put 8 to 10 turns of RG8X on it. You can put about 4 or 5 turns of LMR 400 size on it. But there's also an alternative, which we found you can't put quite as many turns on. You put 4 or 5 turns, sometimes 6 of RG8X. But it's much more convenient. It's a snap-on or a clamshell. And so if you're playing with the position of the choke, which is how you tune these antennas, by the way. When you put it up, and if you don't get the exact same SWRs or close to what we published, you can change the position of the choke for your individual location. You don't change the length of the wire, you just change the position of where the choke is, maybe plus or minus a foot or 2 feet in most cases, just to fine tune a particular SWR for a band or for all bands. But in general, we've pretty much got the positions down for all the different types of antennas. If you're the type of person who wants to do it yourself, we sell every individual part individually. All right, so you can buy the individual different power levels of the unknowns and We also sell complete antenna systems with everything there. All you got to do is add your own coax. And if you don't want to do that, we sell them with coax too as a package price. We also have, these are the 100 watters, and we also have both types of chokes here. But my recommendation is get this choke here. It's much easier to adjust and works almost as well as the ring. The ring's $10 and these are 20. It's not a big difference, but the convenience of adjustment is much better here. And so that's what we ship with everything pretty much now. We do have coax noise filters also, but we'll talk about those in a second here. Now, you have all the parts that you need and some of the diagrams of what you can when you put these antennas up. But one of the things that you may run into is how do you integrate all these things together? Well, we've seen this diagram multiple times now. And essentially you have an antenna, you have coax, you have a choke, and then depending upon the length of coax from the choke all the way back to your radio, you may or may not want to use something called a coax noise filter. And I'll show you in a second how you know you need one or not. All right. But the purpose of these is to take out some of the noise that's picked up by the outside braid of the coax. All right. I think I mentioned this before in the other talk that we gave, is that coax has 3 conductors. All right. The outside metal braid, all right, either whether it's double braided or single braided, doesn't make any difference, has actually 2 electrical conductors. One is in the inside and one is on the outside. And that's because of an electrical characteristic called skin effect. All right, the current only flows in the top 1/25,000th of an inch of the cable. And so the inside of the braid and the outside of the braid are 2 distinct electrical conductors. All right. So when you're pushing signals up the inside with your transmitter, for example, the current goes up the inside of the braid and also the center conductor. And when it gets to the antenna, that current that's coming up the inside of the braid is a fork in the road. It says, hey, I can go down the outside because there's a conductor there, or I can go on the antenna. And what stops it from going down the outside at the antenna feed point is a choke or a balun. We'll stop it. It acts as a stop sign and it says, do not go down the outside of the coax. And consequently, you don't get the radiation problems that are caused if the coax is part of the antenna. In our cases here, we want that to happen. We do not purposely put a choke at the antenna feed point. We go down, in this case, in our picture here, we go down 12 feet because we want it to radiate, but we want to put the stop sign right here so that it sees 12 feet and 55 feet. It sees an off-center fed dipole essentially, and it radiates and it has very good characteristics, SWR and everything else. But okay, let's say you put the antenna in and you got 100 feet of coax, or maybe even more. All my antennas have almost 400 feet of coax on them because I have a couple acres and the antennas are far away from the house. So I use coax noise filters a lot. But here's a real simple test that you can make. And I believe we did this last time, but I'm going to go through it again because it's an important feature. Is if you have a single antenna, all right, we'll talk about antenna switches in a second. If you have a single antenna, the way you can tell whether you're outside of your coax is picking up noise or picking up a second signal. We're saying in a different way. Remember, there's 3 conductors in coax. The outside conductor is an additional receiving antenna in addition to the signal that comes down the center of the coax. So that when you screw in the connector to your radio, you are connecting 2 receive antennas. The receive antenna from the outside connecting to the outside of the coax connector, and that combines with the signal from the center. All right. You pick up noise on the outside. All right. Even though you got a ground here, you're still picking up that noise. The problem is what you want to do is make sure that noise never hits the radio because it biases up all the signals and stuff. So here's the simple test. Take it a minute to do it. What you do is you take your coax and you unplug it And if all the noise goes away, you know that your noise is coming in from the coax. You don't know whether it's coming in from the center or the center and the outside. So here's how you tell. You just put you roll back the outside connector and you just put the center in a conductor in. Do not let the outside touch at all. And measure the noise level, and do this on multiple bands too, because it may be prevalent on 80 and 40, but you may never hear it on 20 meters, for example, because 80 and 40 tend to be a lot noisier in terms of picking up power, AC power line noise. So measure the noise level. Let's say it's S1, S2, S3, doesn't make any difference. Now what I want you to do is screw in the outside and measure it again. All right. And if it goes from like S1 or S2 up to S4, S5, S6, for example, that's like a 3 to 4 S unit difference. All right. And you got to hear that when you're talking to a person, and you may not be able to hear them if you're working digital modes or there's QSB on the signal or not. You may be fading in and out of there because of this noise that's being picked up by the outside of the coax. So we have something called a coax noise filter. And what it does is it acts as a stop sign and prevents that noise picked up by the outside from going into the coax connector at all. All right. It works just the opposite of way a balun works on transmit, which is at the feed point. All right. These are called coax noise filters. They are essentially high impedance baluns. They work very well, and they're one of our best-selling products. So you have a couple options, and I'm going to give you a comparison of how these things actually work. We have the small one here, and we sell hundreds of these per month. They're just really effective. These here, on the average, will get rid of about 38 dB of noise, common mode noise. Not the noise coming down the center, but the common mode noise on the outside. Now, let me put that in practical terms. If we assume that 6 dB is about 1 S unit, 38 dB is a little bit more than 6 S units reduction. Now, that's a lot, all right? These here are rated at 500 watts PEP, conservatively. We make them in larger sizes, both as tubes like this, and also in boxes if you want to mount it to a wall. These here are good for 49 dB, all right? That's over 8 S units, and that's broadband across all the frequencies, not just 80, not just 40, for example, all right? And they go all the way out to 6 meters. Even on 6 meters, they're not quite 49 dB, they're around 35 to 40 dB. Still, that's 6 or 7 S units, all right? That's a big deal. So when you buy a choke, or you buy and we're the only people that sell coax noise filters, by the way. Some other people call them chokes, but they don't give you any specs on them. So when you buy a choke, always look for the specs. Look for a graph like this, or something that tells you what they're going to do. It can't just say choke on it, or line isolator, good from 1 to 30 megahertz. I've measured some competitor ones. In fact, I published them on the website as a comparison to some of these, and they're good at 1 frequency maybe, but they're not broadband at all. And particularly coax chokes, they're useless except at 1 frequency. One thing that we put in some of our chokes, by the way, just an FYI, if you need it, all right, is we put a ground stud on it. But this isn't just an ordinary ground stud. This is actually a static bleeder from the center conductor out to the ground. All right. And the guy that taught me how to do this was Art Bell. When Art was alive a couple of years ago, we used to talk to him all the time with Bob Heil and Joel Walsh, by the way, on 80 meters. And we got into some pretty interesting discussions. But one of the discussions is Art Bell had 2 1,700-foot loops above each other. One was above each other. And he lived out in the desert, and what he would get was wind static. And the wind static would create 70 to 100 volts on his antennas whenever the wind came up, and it would take out all his front ends of his FTDX 9000 radios that he had. So he came up with the idea of using something, or created something called a static bleeder. And we sell them separately. You can put them in a coax T and use them that way. But we now build them into our some of our chokes as an option if you want to use them particularly at the radio end of the coax, and they're very, very effective. It prevents your front end from being blown out if you have lightning in the area or you have wind static or something like that. So nobody else does that, by the way, just us, but that's just an FYI for you. So if you're looking for chokes, look for the specs on the chokes and the frequency range that they're covering. And these here are super ones. I put it in comparison. If you have a sleeve choke, which is just multiple ferrites in a row, they're about 6 to 10 dB. 6 to 10 dB. These are 40, almost 40 to 50 dB in comparison. They're much, much better than normal just feed line chokes. Okay, we'll talk a little bit about where you put these coax noise filters, and I'm going to segue into antenna switches, and then we'll go into one more topic, and then be ready for some questions for you. But if this is your antenna, if this is your radio station, you have a transceiver, you can put a coax noise filter between here and the linear amplifier if you're using one, and your antenna tuner goes here and your antenna switch is here. Now, one of the things that I'm going to tell you about using antenna switches is that most antenna switches only switch the center conductor. They do not switch the braids. So theoretically, all right, now I'm going to jump to another slide here because it shows it. Theoretically, if you got all these antennas out here and you can have balance and chokes on at the feed points, that's okay. But all the way from that point all the way to your antenna switch, you have two receive antennas, right? You got the signal coming down the middle, and then you got a signal that's being picked up by the braid. Now, let's say you got 3 antennas and you got 3 braid currents, and you say, I'm going to select antenna 1. What did you just do? You selected the center conductor of antenna 1, but you still have connected to your antenna switch all 3 braids. So theoretically, you could be receiving the signal on this one, but you're picking up the noise on an antenna that you're not even selecting because it's coming in on the braid. See how that works? So what you have to do is you have to isolate the braids before they get to an antenna switch, all right, to make it work. You can't put them in the common line. If you put them in the common line to the antenna switch, all 3 braids are always hooked together. So at any one point, this transceiver is hooked. If you don't put these in the line, you're always listening to 4 antennas, 3 braids, and whatever center conductor you've chosen. Now, in my case, that was very obvious because I had an antenna here that was next to my neighbor, and he had a solar system, and my other antennas are about 500 feet away. So as I was sitting there choosing my antennas that were 5 feet away, I could hear his darn solar system coming in on my coax into the antenna switch. So I did some experimenting. I said, you know what I'm going to have to do, and this is a picture of my antenna switch here. I have eight antennas on it. I put chokes. I run full power, so I put 3,000 watt chokes on every one of these coming into the antenna switch, except for the dummy load. And it solved that problem. All that solar noise that was being picked up by the braids went away. I did not hear it. So when I now choose an antenna, I only get what's coming in on that antenna. I have no other interference from any of the other braids, because this, even though it's a fancy antenna switch, it still only chooses the center conductor. You see, if you have a simple switch like this with just 2 antennas on it, you can just use 2 simple little chokes like this, run your antennas through here, and now instead of having 3 antennas at any point in time without these, you actually just have 1 antenna that you're connected to. You're not hearing any of the noise from either one of the outside braids. So that's just an FYI. You may not have heard of that concept before, but that's a real good use of coax noise filters, particularly if you're in a high-rise apartment or you're in a high density housing area where you have lots of noise coming from households and or solar systems and things like that that are close to you. Or another way to get it is you have coaxes running through the attic, which are going close to your AC lines, and you have lots of noisy things in your house that are being putting interference into the AC lines, and then that's being picked up by the coax that's close to the AC power lines. So FYI, just want you to be aware of it, and we have solutions for that if you need it. Okay, I'm going to talk just about 2 or 3 slides here about end-fed antenna RFI problems. They're not unlike regular antennas. They're virtually the same, but in our case, we're using chokes on all of them at the radio end. I mean, at the transmitter end, so we don't have nearly as much problem unless you have long receiver coax runs. In general, just keep your antenna and your coax away from house wiring. That includes all kind of satellite feeds, AC power, telephone lines if you're still using a regular telephone, and just keep antennas and that'll keep your antennas and your noise and give you a lot different, a lot lower noise floor. We have kits available, and you can see some of the kits. We talked about those before. We have kits for different transceivers and also for linear amplifiers, all different makes and models. And basically what that does is it keeps the RFI in the unit itself, or it keeps it out of the unit. For example, with a transceiver, this is an ICOM 7300. It's hooked to a computer. The computer may be noisy. This stops some of the noise coming in on the interface lines, for example. So clean up your transmitter and amp first, and then your antenna next. If you have issues within your own house or your neighbor's house, we do have kits for home theaters, alarm systems, garage doors, which is real common, telephones if you're still using, or internet, and then any kind of computer RFI like that. Okay. As before, I think I told you, if you're new to ferrites or you're listening to this broadcast, we always have combination kits, and we have kits for virtually everything. If you're a newbie and you want to start this off, or even buy some additional ones that you've already purchased, if you're not a newbie, just type in the word newbie in the discount code and you'll get 10% off on all the orders through the end of the year. So just want to let you know that we're there to support you, and let you know that there's lots of different options to solve your problems. You can always drop me an email at sales@palamarengineers.com, or try and give us a call, but I get so busy that sometimes I can't answer them all. Okay. Now I'm going to spend about 10 minutes. I'm going to tell you a subject which I find fascinating, which you probably have never heard of. And if you have, you may have already been using it. And I came across this about 6 to 8 months ago, and it has to do with antennas. All right, but it's a unique use of antennas for a unique thing, and here it comes. There's a little bit of information on our website, but I want you to do your own. I'm just going to introduce you to the subject, but I want you to do your own Googling or research and see if it's applicable to you. And here's what it's all about. It's called electroculture. And electroculture is antennas for plants. Boy, that sounds really far out, Bob. And this has been a suppressed technology for many, many years. But my experience has been, and I'll show you some results in a second. But basically what you're going to do is you're going to create an antenna, and you're going to put it in your plants. It doesn't make any difference what type of plant it is, but you can use it, and it gives you healthier plants, faster growth, significantly larger fruits and vegetables. Virtually no fertilizer is needed anymore, and the root structure grows phenomenally well. And it's an easy project to do yourself. So let's take a look at some of the things. Again, it's called electroculture, right? So what is it? Electroculture is a method of applying atmospheric electricity to the fertilization of plant life. We all know there's a magnetic field around the earth, right? We can tap into that magnetic field and utilize that energy and redirect it to energize the roots of the plants. There's lots of different ways to do it. You can use different metals, and you can use different shapes and all different types of things. I just urge you to Google it yourself, but here's some practical applications that I've done. So I plant a lot of potatoes here because I like to eat potatoes, but here's an example of an antenna. All right, this is the antenna right here. All right, it's only about 3 feet tall. All right. By the way, the higher you put the antenna in above the ground, the more voltage it taps into, the higher the voltage is. So you put it up 20 feet, it will tap into about 600 or 700 volts. All right. And it will cover about 250 square feet. All right. You may not believe this now, but just try it and see. But here's an example of potatoes at 2 weeks. And exactly 2 weeks later, they just went, but they've gone bananas. All right. And they really grow well. We have tomatoes, we have peppers, we have all types of herbs and things like that, zucchinis, and it's mind-boggling what happens. That's all I can say. That's my experience, but I'm just introducing it to you, and you take it from there. Now, in terms of what you do with these things, here's an example of how big they are. Right, you can start with small ones for your pot like this. Essentially, this is copper enameled wire. I think it's number 14. I just happen to have a big roll of it, and I just wound it, and you wind it clockwise from the bottom up. All right, clockwise from the bottom up, because you're in the northern hemisphere. It's the opposite if you're in the southern hemisphere. And what you do, I usually put a little pointer on it like this, so it can tap into the magnetic field. And you can make them different lengths and stuff like that. And as soon as we get back to video here, I'll show you one that I have sitting in front of me. But they can be any size that you want. You would take this little antenna, and I use these for all my small pot products, small pots and things like that. And you place the antenna generally south of the plant, right? So, and then what you do is you point that little wire up here, you point it towards the north. So it's aligned with this is a magnetic north, by the way. So you align it with the magnetic field, all right? And what it's doing is it's tapping into that field, all right? The higher that antenna is, the higher the voltage is it taps into, and that induces a current in the coil, which then goes into the plant. And so the plant, then you would generally put this close to the plant in the roots, and it will generate some current in there. And it's a small amount of current, but sit back and watch and see what happens. You can do 2 different pots, one with and without, but you'll find that this is an antenna use that you never would have thought of, but it actually has interesting results. And this was a technology that was based upon Tesla's science in the early 1900s, and the fertilizer companies, for all intents and purposes, covered it up so you didn't know about it. Anyway, check our website. There's more information on this, as well as all the antennas and things. And if you don't know what the website is, I'll show you right here. It's palamar-engineers.com. I wrote down your website too, so I'm going to check that out also. And you can always email me here. This is me, AK6R. I'm the chief engineer. And this presentation is available on the website, both as a PowerPoint and as a Adobe PDF download. So if you want to download it, you're welcome to do that. And with that, I am going to stop this and give it back to, I'm not going to do an additional share. I'm going to get out of this share. Pause the share. There we go. There we go. Stop the share. There we go. All right. Now I'm back. And before I turn it back over, I'm going to show you. This is an antenna that I built. It's a 3-foot piece of bamboo. And the antenna is about 1.5 inches wide. And it sits about 3 feet above the plants. It's very similar to the ones that you saw in the potatoes. And that they just work great. That's all I can say. All right. Any questions or comments or whatever? I am open to them.
Wow. That's all I can say about the electroculture. I live on a farm, actually a flower farm, and you know what the topic's going to be in the morning when my wife gets ready to go to work. We're going to try to do that to encourage the growth of the flowers over here on the flower farm.
Yep.
Appreciate that. And so for us, couldn't see your antenna. It's curled and it goes up by the plant and it goes across the plant pointing north. Is that correct?
Yeah, this is the bottom of it right here. This is you take the enamel off, and then what you do is you wind it clockwise up. And I just put a pointer on it, and I just point that pointer north. All right, there's a little pointer. Oops, let me get over here. Yeah.
So how long is the pointer?
Oh, the pointer's 2 inches, 3 inches.
Okay.
I've made
Okay.
circles out of them. I've done all kinds of designs. Once you start doing a little bit of Googling on it, you'll find that people have used all different types of designs. Fancy, like I say, lots of different ones. I read an article and I watched a YouTube with one person who must have had 10 little raised beds of gardens. And so he put a 20-footer up, and he ran the wire all through each one of the beds, lengthwise in the beds, the same wire. And he took a before and after about 6 weeks apart. And after I saw the 3-foot zucchini, I said, well, I think I'm going to try that. And it was just remarkable. So do a little Googling and you'll be fascinated by it. That's all I can say. I hope you are, just like I was. And they're all end-fed, by the way.
Question on the how many turns of the coil and the diameter, does that matter?
Nope. No, I think mine have, let's see, 1, 2, 3, 4, 5 or 6. It's not really important.
Not
And,
really.
Yeah, I've wound them around wine bottles so that's bigger at the top than it is at the bottom, for example. I've tried to experiment all different types, and it doesn't seem to make too much difference.
Thinking like a broom handle.
Yeah, broom handle is what I use. Yeah. Or small pipe, I just put a small pipe over the bamboo, and then I just wrap the coil around it, or you can just wrap the coil right on the bamboo or anything.
Have you done one clockwise and one clock counter?
Yes, I've done them both. I've done them both ways, and I found that that the clockwise from the bottom up, all right, not from the bottom, not from the top down, seems to work a little bit better. Like if the correct one was 100%, the other one's about 60 to 70%. It's a little bit slower, but it still has results. Right? But I just found that the clockwise up tends to work a little faster.
Okay, back to. Oh, I'm sorry.
Back to end-fed antennas, right?
Yeah. I want to build a vertical, and I noticed you used to have on your website vertical antenna kits, and they used a 4-to-1. And I was just thinking about using a 9-to-1, but this resonant end-fed sounds like it would work great as a vertical. Is that correct?
Yeah, it would work fine. Yeah.
So that'd be 67 feet vertically in the air, and you feed it, feed it. Use the coax to come down to 12 feet, and then you can turn it.
Yeah. If it's resonant, all you need is 55 feet.
55 feet plus 12 feet of coax after
12
the
feet of
choke.
coax. The coax was going to be there anyway. So my thought was, well, why don't you use it? And yeah, you need less wire.
Yeah, my coax will be running underground, so I'm not gonna. I think it'd be better to leave it outside and run it up the tree.
Yeah, well, you could also just make it off center fed, make it 66 feet. And just feed it 12 feet up.
Sounds good.
Yeah, I have a question.
Sure.
I'm using now, and I put my 71-foot antenna up. This is Mark.
Yep.
And I could never really get it to tune up correctly, even using the tuner in the radio. So I had ended up buying a auto tuner especially for 40 meters. A lot of the other bands loaded up just fine. And I used 50 feet of coax. By using a little longer, say like 75 feet, or say a little longer coax, would that have maybe helped that situation to bring that SWR down?
You had the 71 feet.
Yes. Yeah.
Well, all those antennas, those non-resonant antennas, as well as the resonant ones, they rely upon the the matching unit being at a certain position with respect to the entire antenna, right? Just like the off-center fed's got a short and a long, right?
Right. Yeah.
Your long is 71 feet. It in order for it to match on multiple bands, it likes to see a short of about 42 feet, right? So if
Okay.
if it sees a 75 footer, it's gonna see I'm right in the middle of the antenna, and your impedance
Yeah.
your impedance will be messed up. You see what I'm saying? So the answer is no, something else is either loading it or having an effect upon it. But generally you can get away if it's 48 feet or 46 feet or something like that. But
Yeah.
it's close enough if you have an antenna tuner. But we like to make it close to 42 so that most people don't have to keep pushing the button. And
Yeah.
it's close to under 2 to 1 in all the bands. So
Yeah,
I
'cause
would look and see if there's anything else that's influencing it. Or
Yeah. Well, I have it in kind of a flat top, a flat top, kind of and we changed it, and to see if that might change that, and it didn't. So what I just basically did, because my main tuner in the radio wouldn't
Yep.
tune it out. So I just bought me an auto tuner, and now it works great. It
Well,
took care of the problem.
I don't think the problem was there was something I think influencing the antenna because
That's what I'm thinking too.
yeah, and that it sees a big capacitor or an inductor out there with something, and it says, wait a minute, that's going to affect it a little bit.
Yeah.
But
Because I'm using like 21 feet of 221-foot sections of fence top rail,
yeah,
because I don't have any trees, and so we connected. We kind of bolted both ends of that to the chain link fence, and then ran the antenna kind of in a flat top configuration, and so it might be something there.
it might be the chain link fence that's just causing some issues, but as
Yeah.
long as you got it working and it radiates well for you, that's the important thing.
Yeah, and it is now, and it did on every band except 40 meters. So
Yeah.
it was doing good.
Was it a 66-foot long fence?
I don't know how long that fence was. But
It may be resonant at 40 meters, and that's what it was seeing, a big reflector, for example.
yeah, that makes sense.
Any other questions? You're letting me off easy.
I got a question. One more question. Well, I got two or three probably, but I'm trying to give everybody else a break. Let them in there. Power out the antenna. Which antenna do you think could generate the most power? The 71-foot non-resonant or the 67 feet resonant and fed? If you had both of them side by side and you're trying to work 40 meters, which one do you think actually radiates more? Does the 4-to-1 cut less power than the 9-to-1, or does it matter? Or have you done any
It
studies?
doesn't matter. It's all about how it matches the antenna. And so as long as it's matched okay, resonant versus non-resonant radiate exactly the same. It's all about how you're matching them. As long as the match is good, you should be fine. You saw that the 4-to-1 had slightly smaller SWRs on some bands, but on the other hand, it couldn't work some of the other bands that the 40-meter ones could. So the answer is, if I had to put it up in the air, I always prefer an off-center fed versus an off-center fed end fed. But I have found in practice, I really can't tell the difference in terms of signal reports or people that I can work.
Okay, it's good.
So either way should be okay. Well, I can talk about electroculture more.
I have one question about the chokes
There you go.
and
Okay.
the
Sure.
noise filters.
Yeah.
A very simple question. Now you basically, there's a SO, whatever that connection is. I always get it mixed up where you just, screw in the coax on each side. Is there a right way or wrong way to connect that filter or choke?
No, there's not. They're bidirectional, and they will carry a DC current if you have DC biased, if you're biasing something at an antenna switch, for example. So there is no in and out. They're both ins or they're both outs, and they do carry DC current. So
Okay.
it won't make any difference. All our chokes are like that.
Yeah, we were talking about that the other day. We were curious about it, so I thought I'd throw it out there while we have you here. Thank you.
If you're using the ones with the static bleeders, you put the static bleeder towards the radio. If you put the chokes with the static bleeders at the radio end, you would put the coax at the towards the radio. That's the only one that makes a difference.
Okay.
One more, Bob. The bullet antenna has the wing nut for counterpoise. You do not want to run that to a ground rod.
Correct. That's like grounding half your dipole.
I think I've heard someone do that before, and that wouldn't be the case if you had an end-fed half wave. Or would that be the same thing on one of those? Some people have the 49-to-1 and they're grounding rod.
I'll tell you a little secret on end-fed half-waves. They're really off-center feds. They just have a very little counterpoise. But I will tell you, and we sold these for a long time, for almost a year. If you take that end-fed halfway, the 40 through 6 meter one that we had, that only showed 4 dips, 40, 20, 15, and 10. If you take a choke and you put it out about 16 feet, you can work all the work bands. You'll get dips on every one of them. And what that tells me is that it tunes like the bullet antenna, the 71-footer. It's a 66-foot length plus a 16-foot length, happens to be 82 feet. And where that 49-to-1 is, it happens to work not only on the individual harmonic bands, but it also pick up the some of the work bands in between. Not as many as the ones that we have, but it will pick up some of those bands. But you got to put that counterpoise on there. Normally, you would use a counterpoise from 1 to 3 feet on those, and you'll actually get much better operation. But you never ground it. They're not verticals. I mean, they're not 66-foot verticals. And ours aren't either. Ours are basically dipoles. Did I answer your question?
Yes, you did. Now,
Yeah, Bob, for those folks who don't have it, maybe can you describe the construction of the bullet? I mean, that thing is built like a tank.
Mm-hmm.
Yeah, sure. Well, if you're familiar with a solid state amplifier, if you just look at the PC board, it's usually got 2 columns of beads where the output goes. All right, and those are tied to the 2 transistors, for example. Those beads are usually about an inch, depending upon the size. We use beads that are 1 inch long and they're about 1 inch wide. And we use anywhere from 2 to 8 of those, depending upon the power level. But with just 2 beads, 2 small beads, all right. If you were to compare that to a toroid 4-to-1, for example, a toroid 4-to-1 transformer, you got to use 2 big circles, 2 big rings. Each one's going to have on it approximately 2 wires of 48 to 60 inches apiece. Right, and then you're going to put them together in parallel on one side on the primary, and in series on the other side for the secondary. That's a total of 48 times 4, or roughly 200 inches of wire. All right, and because of that, that becomes resonant at lots of different frequencies, right around 21, 22 megahertz. And so you can't get that toroidal transformer to go much above 30 megahertz. Now, I'm going to contrast it the way we do it. What we do is we use two beads, an inch long, an inch wide with a 1/2 inch hole. And we use 12 inches of wire total. That's it. There's two turns through both of those. You put the beads together like you do a binocular, set of binoculars. And you run that wire from the center conductor, or from the ground of the SO239. You run it through once, and then you run it through twice, connected to the center conductor. You run it through 2 more times from the center conductor, and that becomes the output of a 4-to-1. And so now I've got a small amount of wire, which means it's resonant at a very, very high frequency. However, it is flat under 2-to-1, almost to 200 megahertz, and starting at roughly 1.5 megahertz. Right. And the reason they're so wide band is because there's a lot less wire, a lot less labor, so we keep our prices down. All right. And it will take more power because there's less wire too. All right. And we can use a material. We can use 2 beads, and I can put 500 watts of digital through that all day long. They can't even do that with the 2 rings together for the most part. And if they want to go to 5,000 watts, they got to put a huge ring or 5 rings in series. I mean, parallel with each other. We don't. If we got 5,000, we just put 8 beads, 4 in each row, and we're good for 5,000 watts. And then we're only using maybe 30 inches, 40 inches of wire. And they're using, a lot more than that. So we use less wire. We use different materials, and we use the same concept that they use in the linear amplifiers. And as a result, they become very, very broadband and a lot more useful. And they're smaller. And so when we foam them in those bullets, they won't move. They're very sturdy, and they're easy to. You can throw them against a tree practically. In fact, that's how they got their name, by the way. I didn't tell you that before. We had the Boy Scouts over here, and they said, we're looking for an antenna for our Jamboree on the Air. What do you got? I said, here, take a look at this one. And I had just put that together. And I said, throw it over that branch over there and let it land on the ground. So they did. The branch was 20 feet, 15 feet in the air. They threw it over there with the wire, landed on the ground, and went thump. And then they strung the wire out 71 foot. We put the coax on it. And they said, this thing looks like a bullet, because it had a little ream on the bottom of it, for example. I said, that's what we're going to name it. Well, the Boy Scouts ordered 500 of those things for their Jamboree. Right. They use a lot of these on the Jamboree on the Airs. The one they had down here in San Diego, they had 2,000 scouts, and we had, 10 or 15 bullet antennas down there with stations on the air. So that's how it got its name, and they are very robust, let's put it that way. So
a question about lightning. What can you tell us about lightning protection for one of those end-fed antennas?
okay, well, I can tell you that all of our balloons are DC grounded. Right. So that if you took an ohm meter and you went to the output on the top to the ground on the side, you'd see 0 ohms, or very close to 0 ohms. So they're DC grounded. Right. Like any antenna, if a lightning bolt hits it, right, a lightning bolt is going to try and find the ground. Well, the only ground that you really got is the braid of the cable, right? Because the other parts are both floating, so to speak. So it's going to go through the cable, but if it hits the top input, it'll short out to the ground if you have one, and if not, it's just going to follow the cable into the radio station. So it's no worse or no better than any other one, other than it gets rid of static issues fairly easily, because there is no DC. There is a DC continuity between the output and the input. So if you have a good ground at the station, the input will be grounded DC wise. RF wise, it's not, but DC wise, it is. So you're better off doing that than you would be doing some type of fancy 49-to-1 where you have high voltage on it to begin.
So just having a good station ground
Yes,
is really what you need. Yeah.
yeah, you need a good station ground, no matter what, but it helps
Yeah.
with that. Yeah. Our static bleeders are used for, wind static and those types of things. And, to some extent static in the air, but for the most part, they're used as a way to protect your front end of your radios.
Because we get a lot of lightning back here.
Yeah, I'm
Yeah.
sure you do. No, they're not lightning arresters. You should still run, your coax through a lightning arrestor before it gets to the station, so that it doesn't take out your station. But that's always a good idea. These are not meant to be lightning arresters. They're meant to be DC grounded, so you don't have that issue. But they're shorted from that standpoint.
I guess the other question I had was about what versions would be good to be for like parks on the air, QRP type rigs.
And we do a lot of parks on the air, summits on the air, those types of things. And most of the people use those 100-watt versions of the little black boxes that I showed you in one of the slides there. It's 100 watts, and you just use either 55 or 71 feet of wire. But you can also use the 40. It depends upon which band you want to work. If you want to work just 40 and up, you get a 41 feet piece of wire, and then you put your choke down at 16 feet, and now you have 40 through 6 meters. And it's small, it's lightweight, and you can put it on top of bushes, or you can have a little fiberglass pole that goes up and go to a tree or something like that. That's probably the easiest way to get it on the air, make your number of contacts on the different bands, and then go to the next one.
Yeah, I was going to say a lot of them use the either the bamboo or fiberglass. They call them a squid pole, but
Yeah.
basically a telescoping pole, and the wire goes up to the top of it, and then you tie off the end of it off to a bush or something somewhere, so it's kind of a inverted L shape.
Yeah, usually inverted L, and then if you use the short version, the 41-footer, you only need 16 feet. So, and just feed that. Get a 25-foot piece of cable and put your choke at 16 feet. Plug it into your radio on the picnic table, and you're off and set to go.
Yeah, and typically they don't offer anything above 40 meter. Usually it's 20, 30, and 40.
Yep. Well, that's the end-fed half waves are like that. Ours are, a 41-footer will work 40 through 6, and all the work bands.
Yeah, I know 30 is a pretty popular band for a lot of summits on the air.
Yep.
And a lot of summits don't have any trees. So
I think the other thing is that they're doing parks on the air during the daytime, and 80 meters is not a daytime band.
Oh, no, that's true.
There's a lot of guys on 17, I know, and 30. But
yeah,
I mean, that product is still on our website, the 41-footer, and we do sell it to the parks on the air guys, and or summits on the air, and they get the little 100-watt or the small one, and it's cheap, and it's got the wire with it, or you can just buy it individually and put really small wire on it, 24 or 20, 22 or so.
A lot of people on 20 meters doing parks on the air too. Boy, a lot of.
Yep.
Anybody else got anything? Bob's probably about ready to go eat dinner.
One comment, somebody was talking about that you can get things faster if you order it from HRO. I think they said, well, I ordered mine directly from Bob and I got it in 2 days. So don't worry about the speeds.
Yeah, it just depends upon whether we got it in the stock or not. And if HRO's got it, you can get it almost immediately. If we don't have it in stock, I have to have it made, and we have people making stuff for us every day. A lot of independent contractors keep a lot of these old guys busy, and sometimes it takes a couple of days for us to get them.
Yeah, I ordered mine from HRO in Atlanta, and of course, being in Tennessee here, it was on my doorstep the next day.
Oh,
It was
good.
like boom, it was right there, so you got it right out.
They just ordered 200 bullet antennas from us about 3 weeks ago.
Yeah,
Tells
there you go.
That's like every month, I'm saying, you can tell how popular those darn things are.
Yeah. I don't know how many people I've talked to on when I'm up on 20 meters who has one of those, and they sound good. Like we're all like just lots of people just
Yeah.
that happen. Yeah.
Yeah, I'm glad. It makes me happy we've been able to get a lot of people on the air and they're having a good time.
Yeah, we had a new blonde ham email me last week. He just got his general license and just got a TS590 and a voice chip. He says, "What antenna do you recommend?" And of course, I went over to HRO and got the link. Says, "This is the one that we recommend, and it's the one that everybody's using." And I've never heard anybody that was not happy with it.
Well, good. We sell them all over the world.
Yeah, I can actually tune up on 160 on my 71 foot. I think that's kind of cool.
Oh, that's pretty cool. That's pretty cool.
I did that the other day, and with the auto tuner that I have, if you go back and you just push that button, it doesn't retune it, but when you hear a little click click, it's like and it says if it memorizes where you last tuned up, it'll be there, and it did, and it was on 160 meters.
Wow.
It was amazing. I'm like, wow, that's pretty cool.
Anybody ever tried on 6 meters?
Yes, I've made several FT8 contacts on 6 meters with mine.
Oh, good.
A lot of them 10 meters over in Europe.
Yep.
Definitely. But I've got the 97 foot, and I'm running, when I ordered it, it came with, I got the super choke, the big square box choke that come with it.
Yep.
And I got the legal limit version, and you sent me the counterpoise kit. It had a 12 foot and a 15 foot counterpoise. And then I added some more to it. I think I added another 30 or 35 feet more to it. And mine's in the attic, and it's sort of shaped like a C. It goes down 10 feet over the back wall, 30 feet, down 58 feet down the back wall, and then over the end wall. Then I got the bullet, and then I got, like I said, 35 feet of counterpoise going one way, and then the 12 foot going one way and 15 going the other. I got 3 counterpoise on it. Does that matter, having 3 counterpoise?
No.
The more
fact,
wire, the better.
When they first came out, we had 215, a 12 and a 15, I think it was, or 2 15s. And the purpose for that was that, all the summits on the air guys, they only had 10 feet of coax. And so there wasn't enough coax, there wasn't enough counterpoise to make a difference. And so we just put multiple counterpoises on there. Now it's okay to put multiple counterpoises with different lengths. And so what in effect you're doing is you're creating different antennas on different frequencies. So for example, if you had a 42 footer on, and they're all in parallel, and the radio or the electronics will pick out whatever one is more resonant. All right. So if, for example, you put the 42 footer on there, and for some reason you just can't get 30 meters to come in for whatever reason, well, you can put another counterpoise off the side of the matching unit and and adjust it so that 30 meters comes in fine. All right. It might be shorter or longer than the 42 footer. All right. And so what'll happen is when you transmit on 30, it will use that one, but on all the other bands, it'll use a different one. All right. Or it'll use a combination of them. So whatever the impedance is, it'll try and match it the best it can.
Kind of like a fan dipole.
Kind of like a fan dipole, right? You just have fan counterpoises. That's a good way to put it. Yep. And it uses the one that it likes the best.
It's like radials, the more the better.
Yeah.
I hate to interrupt, but I just wanted to say Thank you for the talk. I appreciate it. It's past my bedtime. I gotta go to bed. Good night, guys.
Okay. Good night. Thanks, Shane.
See you, Shane.
Well, Bob, we appreciate it. It's always been very, very informational and informative. I was telling the guys the other day, the InFed talk that you gave to another club, I've listened to it 4 times, and every time I listen to it, I learn something different. I said, I've got to stop. So when I listen to this one, I'll listen to it multiple times, and we'll get credit for it because it's our own video.
Okay, well, that's good. That's good.
I'll tell you what. I think that the thing on the Electroculture, that just blew me away. That just, and so did the stuff on these antennas. You had a wealth of information tonight.
Yeah.
Thank you very much for that.
Are you going to put this up on your on YouTube on your blind hams?
Yes, it'll be on our YouTube channel. It'll be on our podcast also, and I'll send you links to both of them.
Yeah, send me a link and then I will put it up on our website. Because when people look at the presentations, I can say, well, it's available here, which means people will go watch it there.
Great. Appreciate
Wow,
that.
that's good.
I'll do that. That'll help you guys out.
All right, Bob. Anybody got one more time? Let's go. Last call for questions.
All right, it's been my pleasure as usual. And I'll have some more dreamed up in the future that I'll tell you guys about.
Keep in touch. We'll be glad to have you back,
All right.
Yes.
Yep. Thank you.
Always a pleasure.
Thank
being
you.
here. I'm going to sign off and I'll see you guys later, and give me a call if you need to, or drop me an email and we'll try and answer your questions.
All right, Bob. 7:30.
Thank you very much.
Thanks,
7-3.
Bob. I'll be
Yep.
dropping by to get a choke from you.
Okay. Fine.
Yep.
Very good.
Thanks for the presentation.
All right.
Thank
you're
you,
welcome.
sir. Have a
Yep.
great night. Yep.
All right. You too. And send me that link. I'll get it fixed up for you tomorrow.
I will.
Yeah. Bye-bye. Thanks, Joel.
Is that a
Well, now to
wrap,
plan my
Angelo?
vertical in the morning.
I told you not to buy anything before tonight, didn't I?
Yep. I think that's the way I'm gonna go. The other way was just way too much and way too much work.
So what are you going to do? A 71 foot, or are you going to do the end-fed resonant?
It's gonna be between the two. I'll probably decide in the morning. I'll see what kind of space, what I got for runs, and
And why don't we let Julia tie the ribbons on this, and then we can go into our casual chat.
Oh, I thought we did.
oh, I thought we were done.
Oh.
Okay.
We
Go ahead,
can be,
Julia.
but he likes to give us a farewell there.
Yep.
Oh, sorry,
All
Joe.
right. No problem. We'll just go ahead and do this quickly. And that's a wrap. So thank you all for coming. Thank you for listening. Remember to check us out at www.blindhams.com. And most importantly, look us up on YouTube. Look up CQ Blind Hams and subscribe to it if you haven't. Get your friends to subscribe and watch this and many other informative podcasts and videos that we've got up there. So until next month, I believe that's going to be September 14th, if I'm not mistaken. This is CQ Blind Hams Techzoom 730.
7-3.
7-3.